If someone told you there's a way to prevent 260,000 premature deaths, 700,000 asthma-related hospital visits, and 25 million tons of crop loss every year, would you consider it? Reducing methane has a dramatic impact in protecting our climate, our health, and our future. Methane is 86 times more potent than CO2, which means it traps heat much more effectively. The good news is, methane is short-lived, taking only a decade to break down while CO2 lasts for centuries. A recent UN report described methane mitigation as the strongest lever we have to slow climate change. There's a potential to reduce emission by 45% this decade, reducing global warming by 0.3 degrees Celsius before 2045. So where does it all come from? Oil and gas sector accounts for the largest source of human-made emission, followed by livestock and landfills. Emissions occur across the value chain from production to processing to distribution. However, around 75% of the emission today could have been avoided.
Industry experts have described this as mostly a plumbing problem, since the remediation requires fixing pipes and tanks. The real challenge lies in detection and quantification. Methane is odorless and colorless and requires special equipment to detect. And quantification is inaccurate, relying on engineering estimates based on quarterly inspections. The current approaches regularly miss the largest leaks, which account for 5% of the leaks but contribute to 50% of the total emission. The current approaches include manual inspection via handheld sensors, which is the minimum required by the EPA. This helps pinpoint which equipment is leaking, but it only occurs a few times a year and is time and labor intensive. Another option is periodic monitoring via satellites and airplanes. This helps to understand concentrations in a broad area but does not tell you which equipment is leaking. We looked at this problem and wondered, how can we help our clients continuously identify the source of methane leaks in a cost-effective manner? Our solution idea is to mount low-cost sensors on equipment in the field to collect data about methane concentrations as well as environmental readings such as wind speed and temperature into a cloud-based data and analytics platform. We combine this with data about the physical assets and the production operations. This information will enable a better understanding of why leaks occur. It can also enable prediction of when leaks might occur in the future. All of this allows our clients to undertake targeted, preventative, and remediation actions. Our solution provides a number of benefits. The continuous monitoring greatly reduces expensive and time-consuming truck rolls. More importantly, it enables equipment repair in a timely fashion, reducing lost product revenue. As investors and regulations increase pressure to take climate change seriously, this allows companies to credibly demonstrate that their methane emissions are under control. Also, as market-based mechanisms like carbon pricing take shape, solutions like this will become necessary.
We needed a way to collect and transmit environmental readings to the cloud for analysis. We started with a microcontroller that allows us to program it. We added to that a very large methane sensor and a much smaller environmental sensor, which gives us temperature, humidity, and barometric pressure. Combining all of these into a low power, very small and unobtrusive unit, we can send data to the cloud.
The key architecture components are API gateway for receiving messages, Lambda function for message handling, S3 object storage for storing files, Glue for ingesting the S3 file content into Postgres, Postgres database for relational model, Tableau for reporting and dashboard, SageMaker ML models and APIs for model creation and serving, and SNS notification for triggering alerts and messages.
Consuming data from AWS, we built an interactive Tableau dashboard that allows LDAT teams to get near real-time actionable insights on methane leakage. The map visualization helps to quickly identify problematic equipments through color coding and prioritize actions. The tool identifies correlation between external factors that may cause leakage like suction pressure. Filters on top allow to slice and dice and identify additional contributing factors such as equipment manufacturer or years in service.
By incorporating advanced statistical methods and machine learning techniques such as supervised learning and image classification, we can build out automatic leak detection algorithms. Leveraging advanced analytics can provide more tailored predictions for specific leak scenarios.
We have a clear vision of where we could take this solution. There are many different data sources we can include. We can more tightly integrate this to client operational systems, and this data could feed client ESG reporting. We can also clearly see partnering opportunities and ways to expand this concept to other industries. We have already identified several opportunities. Pioneer is participating in a research project to evaluate methane sensor technologies at actual drilling sites. Microsoft has a solution accelerator for methane monitoring and are looking for an implementation partner. We also have a pursuit with a prospect who provides software to E&P companies. They are interested in adding ESG capabilities to their software, including methane monitoring. These activities indicate that we have identified a unique solution that is highly relevant in the market.
Come join us, the Meth Busters team. If it's worth doing green, then it's worth overdoing green too.